In example 5, we're told that the profit of a company increased steadily over their first 10 years. In this case, that increasing steadily means we had a constant rate of increase. We can use a linear function to model this scenario. The following profit function gives the company's total profit in thousands of dollars for producing and selling X units in hundreds over that 10-year period. What we want to do is find and interpret both the y-intercept and the x-intercept. In Wolfram Alpha, we can find those intercepts by simply asking it for intercepts for y equals 28.36x minus 578.06. A single command tells it to find all intercepts for the function that we gave it. And so we get x is approximately 20, y is approximately negative 578 as our x-intercept and our y-intercept. So the y-intercept that we found was 0, negative 578.06. And the x-intercept that we found is 20.3829, 0. What we want to do is interpret those results, keeping in mind a couple of additional pieces of information. The company's total profit is in thousands of dollars. That means we need to take this y value, that profit, times 1,000. So the actual value in dollars is $578,060. Well, negative $578,060. And our units that we've produced and sold, X, is in hundreds, meaning we need to take our X coordinate, our X value, and multiply that by 100 to get 2038.29. Now we need to interpret those results. Looking at our y-intercept, that occurs when our x value is equal to 0. So that's units produced and sold. So if that's 0, that means we haven't produced anything, we haven't sold anything. This value reflects essentially our startup costs. Before we actually start producing and selling any items, we have invested or spent $578,060 to begin production. So let's be clear. Let's change that to spent. Our profit is negative, meaning we've spent money but haven't brought anything in yet. Now looking at our x-intercept, our y value, our function value, is 0, and that's our total profit. We started off with a negative total profit. Eventually our company will become profitable because our profits will become positive. But when our total profit is 0, that's our break-even point. So our company will break even once they've produced and sold 2,038 units or 2,039 units. 2,038 would be just a little bit short of our goal. So what we have to do is actually just know intuitively to round that up. We need to produce and sell at least 2,039 units to clear that break-even point. And we could be a little bit more specific once they've sold at least 2,039 units. Because again, if we rounded that down, we'd be below that threshold, we'd still have a negative profit. Then we want to predict when the company's profits will exceed $1,097,010. Keep in mind the first thing that we need to do is divide this by 1,000 because the function gives us total profit in thousands of dollars. So this is 1097.01. And what we need to do is solve our equation set equal to this value. So we'll solve our model set equal to 1097.01, and we get in approximate form 59.065. But our value for x is in hundreds of units, so we need to take that times 100 to get 5,906.5. Rounding that to the nearest whole number tells us that when the company has produced and sold, well, actually making a point of rounding that up, because if we round down, we'll be short of that goal. So we round that value up, because when the company has produced and sold 5,907 units, we'll have met that profit that was stated in the problem. We'll actually have exceeded it by just a little bit, but at 5,906 units, we'd be just under that goal.